Picture this. You're standing in front of the Colosseum in Rome. It's been there for almost 2,000 years. Earthquakes, wars, time itself, nothing could bring it down. Now imagine trying to build something today that would last even 100 years without constant repairs. Sounds impossible, right? Here's the crazy part. The Romans had a secret recipe for concrete that was so good, so incredibly strong, that we still can't figure out how they did it. And I'm not talking about some ancient mystery that doesn't matter. I'm talking about a formula that could literally change how we build everything today. Modern concrete? It starts cracking after 50 years. Roman concrete? It gets stronger with time. While our bridges crumble and our buildings need constant fixing, Roman structures are still standing strong after 2 millennia. Today, we're going to dive deep into one of history's greatest engineering mysteries. We'll discover why Roman concrete was so special, what modern scientists think they know about it, and why despite all our advanced technology, we still can't recreate their magic formula. By the end of this video, you'll understand why some of the smartest engineers in the world are obsessed with cracking this ancient code, and why the answer could revolutionize construction forever. Let me blow your mind with some numbers. The Pantheon in Rome, that massive dome with a hole in the top, was built in 126 AD. That's almost 1900 years ago. Today, it's still the world's largest unreinforced concrete dome. No steel, no modern supports, just concrete. And it's in perfect condition. Meanwhile, here in the modern world, we're constantly fixing highways, replacing bridges, and dealing with cracking buildings. The interstate highway system in America? Built in the 1950s and already falling apart. We spend billions every year just trying to keep our concrete structures from crumbling. But here's where it gets really weird. Scientists have been studying Roman concrete for decades, and they keep discovering things that shouldn't be possible. When they look at ancient Roman harbors underwater, they expect to find concrete that's been eaten away by saltwater. Instead, they find concrete that's actually gotten stronger and more durable over time. Think about that for a second. Our concrete dissolves in salt water. Roman concrete thrives in it. The Romans built incredible things that we struggle to match today. The Hoover Dam? Engineers said it would take 125 years to fully cure and reach maximum strength. Roman concrete seems to reach peak strength and then just keep getting better forever. This isn't just about old buildings being tough. This is about a fundamental difference in how the concrete works at a molecular level. Modern concrete is basically a bunch of ingredients mixed together that slowly fall apart over time. Roman concrete is like a living system that repairs itself and grows stronger. Scientists call this self-healing concrete, and it's become the holy grail of modern construction. Companies are spending millions trying to recreate what the Romans did with simple, natural materials nearly 2,000 years ago. The most frustrating part? We know what ingredients they used. We can see the recipe written in ancient texts. We can analyze samples under powerful microscopes. But when we try to make it ourselves, it just doesn't work the same way. It's like knowing all the ingredients for Grandma's secret cookie recipe, but somehow never getting the cookies to taste right. Except instead of cookies, we're talking about a technology that could save the world billions of dollars and make our infrastructure last for centuries. The Romans weren't just good at making concrete, they were impossibly good at it. They were so far ahead of their time that we're still trying to catch up. And the craziest part? They probably didn't even realize how revolutionary their concrete was. To them, it was just the normal way to build things. But for us, cracking this code isn't just about understanding history. It's about potentially solving one of the biggest problems in modern construction. How to build things that actually last. What do you think? Have you ever wondered why ancient buildings seem so much more durable than modern ones? Drop a comment below and let me know your thoughts. Now let's get into the nitty-gritty of what made Roman concrete so special. And trust me, the answer is going to surprise you. First, let's talk about what we use today. Modern concrete is pretty simple. Cement, water, sand, and gravel. Mix it up, pour it out, wait for it to dry. The cement we use is called Portland cement, and it's basically limestone and clay heated up to super high temperatures until it becomes a powder. The Romans? They did something completely different. Their secret weapon was volcanic ash. But not just any volcanic ash. Specific volcanic ash from around Mount Vesuvius, the same volcano that buried Pompeii. They called this ash pozzolan, and it was like magic dust for concrete. Here's the cool part. When you mix this volcanic ash with lime, which comes from heated limestone, something incredible happens. Instead of just creating a paste that holds rocks together, you create a chemical reaction that keeps going for years, decades, even centuries. Think of regular concrete like a sandwich. You've got bread, cement, filling, rocks and sand, and everything is held together by the paste between them. Over time, water gets in, the paste breaks down, and your sandwich falls apart. Roman concrete is more like a living organism. The volcanic ash contains tiny glass particles and minerals that slowly react with seawater, groundwater, and even moisture in the air. Every time water touches the concrete, instead of breaking it down, it actually triggers more chemical reactions that make the concrete stronger. But here's where modern scientists got confused for the longest time. When they first analyzed Roman concrete, they found these white chunks scattered throughout. For years, they thought these were just impurities, mistakes in the mixing process. They were so wrong. Those white chunks are actually lime clasts, basically tiny pieces of lime that didn't fully mix during the original construction. Scientists thought this was sloppy work. Turns out, it was genius engineering. When cracks form in Roman concrete, and they do form, everything cracks eventually. Water seeps in and hits these lime clasts. The lime clasts then dissolve and recrystallize, literally healing the crack from the inside. It's like the concrete has its own immune system. Modern concrete just sits there and takes damage. Roman concrete fights back. The Romans also used a different kind of lime than we do today. They made it from limestone, just like we do, but they processed it differently. They heated it at lower temperatures for longer periods, which created a more reactive form of lime that worked better with their volcanic ash. And get this, the Romans were incredibly picky about their water. They knew that different types of water would create different types of concrete. Seawater, fresh water, mineral-rich water. They chose specific water sources for specific projects. For underwater structures, they actually preferred seawater because it helped activate the volcanic ash in ways that fresh water couldn't. They were doing advanced chemistry without even knowing what chemistry was. The mixing process was different too. While we mix our concrete fast and pour it immediately, the Romans took their time. They mixed smaller batches, worked the material more thoroughly, and built up their structures layer by layer. They also added organic materials, things like blood, eggs, and even urine. Before you say, gross, these organic compounds actually improved the concrete's flexibility and durability. They were natural plasticizers, making the concrete easier to work with and more resistant to cracking. But perhaps the most important ingredient was time. Roman concrete was designed to cure slowly, over many years. Our concrete needs to be strong quickly because we're impatient. Roman concrete prioritized long-term strength over short-term convenience. The result? A material that gets better with age instead of worse. Have you ever noticed how some old things just seem built better than new things? What's the oldest structure you've seen that amazed you with its durability? Let me know in the comments. So if we know all the ingredients, why can't we just make Roman concrete today? This is where the story gets really interesting, and really frustrating for modern engineers. The first problem is that we've been approaching this all wrong for decades. When scientists first started studying Roman concrete in the 1800s, they looked at it through the lens of modern engineering. They assumed the Romans were just doing a primitive version of what we do today. Big mistake. The Romans weren't making inferior modern concrete. They were making something completely different, something that followed entirely different rules. Modern concrete is designed around one principle: get hard fast and stay hard. We want to pour a foundation on Monday and start building on Tuesday. Speed is everything in modern construction. Roman concrete was designed around a different principle: get stronger forever. They were thinking in terms of centuries, not months. This difference in philosophy creates totally different materials. Our concrete is like a rock, hard, brittle, and when it breaks, it stays broken. Roman concrete is more like a living crystal that grows and heals itself over time. The second problem is raw materials. That special volcanic ash from Mount Vesuvius? You can't just go dig it up anymore. The specific type of volcanic ash the Romans used formed under very particular geological conditions thousands of years ago. Modern volcanic ash is different. Scientists have tried using volcanic ash from other volcanoes around the world. Sometimes it works okay, but it's never quite the same. It's like trying to make pizza with a different type of flour. You might get something edible, but it won't be authentic Neapolitan pizza. The lime is another issue. Modern lime production is all about efficiency. We heat limestone to very high temperatures very quickly to make lime as fast as possible. The Romans heated their limestone slower and at lower temperatures, which created a different type of lime with different properties. When modern engineers try to replicate the Roman process, they run into the third problem: time and cost. Remember how Roman concrete was designed to cure slowly over many years? In today's construction world, that's completely impractical. Imagine telling a construction company that their concrete won't reach full strength for 5 years. Imagine telling a city that their new bridge will need a decade to fully cure before it can handle heavy traffic. Nobody would accept that. We've built our entire construction industry around fast-curing concrete. All our equipment, all our techniques, all our schedules are designed for materials that work quickly. Switching to Roman-style concrete would mean completely rethinking how we build everything. The fourth problem is quality control. The Romans had master builders who understood their materials intuitively. They could tell by feel, by smell, by experience when their concrete was mixed perfectly. They passed this knowledge down through generations of craftsmen. We've replaced that human expertise with machines and standardized processes. Our concrete mixing is automated, precise, and consistent. But it's optimized for our modern materials, not Roman materials. When researchers try to make Roman concrete using modern mixing equipment, something gets lost in translation. The mechanical mixing process doesn't work the same way as the careful hand mixing the Romans did. The fifth problem might be the biggest one. We're not even sure we understand all the variables yet. Every few years, scientists discover something new about Roman concrete that changes their understanding of how it works. Just recently, researchers realized that the Romans might have been doing hot mixing, adding dry lime directly to hot volcanic ash and letting them react while mixing. This creates different chemical reactions than mixing everything at room temperature. Other studies suggest that the specific clay minerals in Roman bricks, yes, they ground up old bricks and added them to concrete, played a crucial role in the self-healing properties. Some researchers think the organic additives were more important than anyone realized. Every new discovery makes it clear that Roman concrete wasn't just a different recipe. It was a completely different technology based on principles we're still trying to understand. The most frustrating part for modern engineers is that we're so close, yet so far. We can make concrete that mimics some properties of Roman concrete. We can make concrete that self-heals. We can make concrete that works well in seawater. But we can't make concrete that does all of these things at once, the way Roman concrete did naturally. It's like trying to reverse engineer a smartphone when all you have is a flip phone. You can see what it does, you can figure out some of how it works, but recreating the whole thing is incredibly difficult. What's your take on this? Do you think we're overthinking it, or is there really something special about ancient techniques that we've lost? Share your thoughts below. The race to recreate Roman concrete isn't just academic curiosity. It's become a multi-billion-dollar quest that could revolutionize how we build the world. Let me put this in perspective. The American Society of Civil Engineers says we need to spend over $2 trillion just to fix our crumbling infrastructure. Roads, bridges, buildings. Everything is falling apart faster than we can repair it. If we could make concrete that lasts 2,000 years instead of 50, we wouldn't just save money, we'd completely transform civilization. Imagine never having to worry about potholes, crumbling bridges, or building maintenance. Imagine infrastructure that gets better with age instead of worse. That's why some of the smartest people in the world are obsessed with cracking this Roman code. At MIT, researchers are using artificial intelligence to analyze thousands of Roman concrete samples. They're feeding data about chemical composition, crystal structure, and environmental conditions into machine learning algorithms, hoping to find patterns that human scientists missed. The AI has already identified several previously unknown correlations between specific mineral ratios and long-term durability. It's like having a superpowered detective that can spot clues in the data that humans would never notice. In Italy, scientists are literally rebuilding Roman-style kilns to understand how ancient lime production worked. They're experimenting with different firing temperatures, different types of limestone, and different cooling processes to see how each variable affects the final product. One breakthrough came when they realized that Roman kilns weren't just hotter or cooler than modern ones. They had completely different heating patterns. Roman kilns heated up slowly, maintained steady temperatures for days, and cooled down gradually. Modern cement production is all about speed and efficiency, with rapid heating and cooling cycles. When researchers tried the slow Roman method, they got lime with completely different properties. Lime that reacted with volcanic ash in ways that modern quick-fired lime couldn't match. Japanese researchers took a different approach. Instead of trying to recreate Roman concrete exactly, they're using the principles behind Roman concrete to create new types of self-healing materials. They've developed concrete that contains dormant bacteria. When cracks form and water gets in, the bacteria wake up and start producing limestone, which fills in the cracks. It's not exactly like Roman concrete, but it achieves the same self-healing effect using modern biotechnology. Swiss scientists are working on concrete that contains tiny capsules filled with healing agents. When the concrete cracks, the capsules break open and release chemicals that harden and seal the crack. Again, it's a modern solution inspired by ancient principles. But perhaps the most interesting work is happening at the University of Utah, where researchers think they've figured out one of the biggest missing pieces: the importance of hot mixing. Remember how I mentioned that Romans might have mixed dry lime with hot volcanic ash? The Utah team tried this approach and discovered that the chemical reactions during hot mixing create entirely different compounds than room temperature mixing. These compounds form crystal structures that continue growing and evolving for years after the concrete is poured. It's like the difference between planting a seed and placing a rock. One keeps growing, the other just sits there. Their hot-mixed concrete shows remarkable self-healing properties. When they create artificial cracks and expose the concrete to water, the cracks heal themselves within weeks. Companies are starting to pay attention. BASF, one of the world's largest chemical companies, has invested millions in Roman concrete research. They see the potential for creating concrete products that could dominate the construction industry. Imagine being the company that finally cracks the Roman code. You wouldn't just have a better product. You'd have the concrete equivalent of the iPhone, something so revolutionary that it makes everything else obsolete. But there are still huge challenges. Even if we figure out how to make Roman-style concrete, we need to figure out how to make it economically. Roman construction projects took decades and used hundreds of skilled craftsmen. Modern construction needs to be fast and cheap. Some researchers think the answer lies in hybrid approaches, using Roman principles but with modern materials and techniques. Instead of volcanic ash from Vesuvius, maybe we can use engineered volcanic glass. Instead of slow curing, maybe we can use additives that accelerate the beneficial chemical reactions. Others believe we need to completely rethink how we approach construction. Maybe some projects should use slow-curing, ultra-durable concrete even if it takes longer and costs more upfront. For critical infrastructure like nuclear power plants or major bridges, the long-term benefits might justify the initial investment. The most exciting possibility is that understanding Roman concrete might lead us to discover entirely new materials. By studying how the Romans achieved self-healing properties, scientists are developing self-healing metals, self-healing plastics, and self-healing electronics. We might be on the verge of a materials revolution that goes far beyond concrete. Imagine phones that fix their own cracked screens, cars that heal minor dents, or buildings that repair earthquake damage automatically. The Romans probably never imagined that their concrete formula would still be puzzling scientists 2,000 years later. They were just trying to build things that lasted. But in doing so, they created one of history's greatest technological mysteries, and potentially the key to building a more durable future. What kind of self-healing technology would you want to see? Buildings that fix themselves, or maybe something completely different? Let me know what you think in the comments. So there you have it, the incredible story of Roman concrete, a 2,000-year-old technology that we still can't fully understand or recreate. We've seen how the Romans created concrete that gets stronger with time, heals its own cracks, and outlasts anything we can build today. We've explored the secret ingredients: volcanic ash, special lime, and even organic additives that seem almost magical in their effectiveness. We've discovered why modern engineers are struggling to crack this ancient code, from missing raw materials to completely different approaches to construction and time. And we've looked at the cutting-edge research happening right now, as scientists use everything from artificial intelligence to bacteria to try to unlock these ancient secrets. The most amazing part of this story is that we're not just talking about the past, we're talking about the future. Cracking the Roman concrete code could literally change how we build everything, from roads to skyscrapers to underwater structures. Every time you drive over a pothole or see a crumbling bridge, remember that somewhere out there, Roman structures are still standing strong after 2,000 years, quietly holding the secrets to building things that truly last. If you found this deep dive into ancient engineering as fascinating as I did, make sure to hit that like button. It really helps the channel reach more people who love this kind of content. And definitely subscribe because we're just getting started with these incredible stories about lost technologies and ancient mysteries that still baffle modern science. Next week, we're diving into another mind-blowing topic that I guarantee will change how you see the world. What lost ancient technology should we explore next? Drop your suggestions in the comments below. I read every single one and your ideas often become future videos. Thanks for watching, and I'll see you in the next one.